And I'm happy to introduce you to our event moderator, Carl Jeffrey, founding editor of Digital Ship, who is currently editing Tanker Operator magazine. Also, you see the first session speakers connected here with me. Carl, I think it's time to start our discussion. On to you.
So this is the event we were going to do at North Shipping. So when we're doing it this way, you've got to pay for your own coffee, you have to pay for your own lunch, and you pay for your own heating, but there might be advantages to doing it this way as well. So you've got the 3 one-hour sessions with a 1-hour gap between them. The first orientated around data, the second on decisions, and the third on crew. But all aspects of vessel performance involve data, decisions, and crew. So it's more of a kind of angle rather than splitting the subject matter up. So to introduce this session, we've got 2 presentations about 15 to 20 minutes long, and then we'll have questions for both at the end. So put your questions in the Q&A box at any time. And first, we're going to hear from Lars Petter Revheim, who's head of maintenance and performance optimization with Höegh LNG. Höegh has 10 floating storage regasification units, although some are sailing, and 2 which are LNG carriers, and he's based in Oslo. And then we're going to hear from Michele Sciannone, who's manager of Marine Digital Advisory Solutions at RINA, who's based in Genova, Italy. So I'll introduce Lars first. He's going to talk about his experience making decisions with data with advanced digital tools for performance management that Höegh invested in over the past 3 years. And he's been started with Höegh as project engineer 12 years ago, and then he's held roles of project superintendent, senior technical manager, and currently the role is head of maintenance and performance optimization with a speciality of floating LNG solutions. And he's got a background as a process engineer. So I'd like to invite Lars to give his talk. Thank you.
Yeah, thank you. Thanks for this opportunity to present a bit on what we focus on in our company. I will then try to share my screen again. I make it work.
Yeah, that's fine.
All right. It is a big topic. Using digital tools to manage and reduce carbon was the topic for this session for me. Of course, that is something which can be looked at as a magic solution. We can use digital tools to manage and reduce carbon. If only it was that simple. So I will come a bit into during the presentation what we believe we can focus on and where our efforts matter the most. I have been thinking a little bit on how to present this, and it is quite a lot of buzzwords now in the industry, focusing on energy efficiency, digitalisation, carbon, greenhouse gas strategy. Yeah, you can see all the words in the word cloud. It takes, you can imagine, it takes a steady hand to navigate this landscape and to fulfill all stakeholders' expectations. There are a lot of various interests. All of them are kind of going in the same direction. Shipping needs to reduce the emissions from the operations by quite a lot in quite a short time, really. But inside of that main objective, there are many things that needs to be on top of the agenda at all times. So what can be the correct strategy to do this? In Höegh LNG, we believe that we can focus on making an impact where it matters. For us, it means make the operators on board able to do the right things and to take the correct decisions. In today's world, there are lots of opportunities to support the operators on board through, for instance, live data transfer to shore and support from shore, which we focus a lot on. That gives a modern operation. We then get a live view of what is happening on board, and we can support online. We can also support in project startups, commissioning activities live, and not having to rely on emails and scanned trends. We can actually look at the developments directly through our data harvesting system. And in the context of reducing carbon, I think one easy to relate to analogy is to our own household. It is, at least in Scandinavia, and I guess in UK and in Europe, the electricity prices are pretty high at the moment. So it's always the same saying that we have in the back of our mind. I mean, the cheapest kilowatt hour is the one we do not use, and the analogy to shipping is basically the same. We have installed power generators on board, and the kilowatt hour which emits less carbon is the one which is not being produced in the first place. So energy efficiency is key to reduce carbon. And how do we achieve good energy efficiency? Well, we believe that we can achieve it by making our operators do the right decisions and support them from shore. So I will come a bit into kind of history, what we have done, and then take a few examples just to kind of give you a flavor of what we are focusing on. We have been on this kind of digitalization journey for a little while. In 2017, approximately, all focus was on digitalization, and that was the stop in a way. Digitalization, digital transformation for efficiency purposes, and then talking about basically work processes and automating was the focus. We see a little bit that this is now shifting to decarbonization. But I think the two things, digitalization and decarbonization, go a bit hand in hand, really. We see now that regulations are moving faster than ever. IMO are making decisions pretty fast, coming up with energy efficiency schemes. Financial world has already for some time and are still using strict requirements for having beneficial financial agreements. And again, digitalization and decarbonization are, in our view, connected. We are only able to influence the operations and be excellent at energy efficiency, achieving a good CII, achieving a good EEXI by having insight. And the insight comes in our company through taking live data from our vessels to shore. We then have in my group a dedicated set of people who are focusing on guiding the vessels and striving to achieve best possible performance of the vessels. So again, going a bit back to the strategy, make impact where it matters, make better onboard decisions. We have, said it many times now, a live data transfer, approximately 1,000 data series per vessel transferred to the cloud. And each of the 1,000 data series is then giving a 1 hertz frequency, approximately, at least once per second, we can see an update. That, of course, is a step change in the ability to guide and advise our operators. We can also remotely log into an operator station on board, which is only having read writes, so that we can, in addition to those 1,000 data series that we replicate to the cloud, we can log on to the vessel and see actually the full operator integrated automation system. That is something we have used with success in commissioning of new regas projects. That means that we can look at bottlenecks, we can look at, we can get in the the expertise from the system providers and look together with the crew on board at the same time at what is happening. So looking at alarms, looking at trends, looking at trip reasons, and we can then troubleshoot and help what is going on, and that saves us quite a lot in time and also quite a lot in travel cost when we are able to do this kind of remote commissioning support. That helps a lot. So it's quite a different situation now in 2021, 2022 compared to, say, 10 years ago for having insight into the operations. Earlier, one was reliant on once per 24-hour noon report coming in, interpret it as best as we can, and then wait for the next update next day. It's not like that anymore. We are now able to guide and to influence the decisions basically in real time. And then, of course, it is a responsibility on our guys at the office not to bother the crew on board too much, because it is a hectic working day on board, and we need to kind of be wary of that they have quite a lot of things to do, and we shouldn't pester them with questions left, right, and center all the time. But we should focus again where it matters. So an example which is shown here on the screen is an overview of our cargo tanks, and we can hear in the LNG segment it is important to keep an eye on what is the tank pressure. So we have a development of that over the last 14 days. Also an overview of key valves and key and the pumps inside of each tank, so that we know what is going on. I'll come a bit back to it. You see here one pump symbol is green, that means it is running. In this tank, when this pump is running, when the pump is running, it of course creates heat, which dissipates into the LNG, which is not beneficial for the cargo. We want to reduce that heat input to the cargo as much as possible. So it would have been better in this instant if this pump was not running. It is running for a purpose, but we have seen through a lot of studies and talking to suppliers that we can optimize the operation around this pump, which I'll talk about in this slide, I think. I have two example cases, one focused on a vessel which is trading as a LNG carrier, and one which is focusing on operation as FSU. So the first one is related to optimal running of the gas management system on board. The gas management system is what is delivering fuel gas to the engines, and it needs to be operated in a way which is as energy efficient as possible. That means avoiding unnecessary consumption, and we can focus on the details from shore. If you relate back to the previous slide, this pump here, which is running, it means that LNG is being supplied for cooling purposes of this compressor. That has been kind of the way to go for all LNG carriers in many years. We have investigated a lot, and we see that we are able actually to stop that cooling on this compressor for certain parameters. Basically, when the ship is sailing at steady speed, open sea, we have an opportunity to reduce the spraying or even stop it completely. And if we stop it completely, it means that we reduce the heat input to the tanks. We then optimize the boil-off gas which is being created, and we consume less, basically. That is something which makes a difference now, at least now with the very high gas prices, which is seen all over the world. So for our charters, each molecule which is being delivered at the discharge port has quite a lot of value, and optimizing this as much as possible is very important. So I won't go into more details than that, but the gas management system on board, we are able to guide the operators on optimal use of through this data transfer solution, which we have from the vessels to shore. This is also reducing carbon because it means it basically means less consumption of gas, less emissions also out the exhaust. Another example is when we operate as a FSRU, we also at 5-yearly intervals have to do the class renewal survey. And that basically usually means that we have to go into each cargo tank to inspect and see that the tanks are in good condition. For Hög Grace, which is operating in Colombia, we were the first vessel in the LNG fleet to get a so-called ASP notation from DNV. That means Alternative Survey Program. That basically means that we take data from a motion registration unit on board, gather all the data, and we can check the data when the time comes for a new class renewal. If everything is within certain parameters and certain limits, then it means that we can avoid opening the cargo tanks for inspection. So the goal, as I was written, is to have control over all relevant parameters to avoid opening of all cargo tanks for physical inspection. That represents a significant cost saving in terms of time spent to gas-free tanks, inert tanks, make it ready for inspection. It represents also a very large risk reduction because it is, I think, proven for all in the LNG industry that the most damage done to the tanks is perhaps when people are entering the tanks and going inside. They are very delicate tank systems, and it doesn't take much to damage if you kind of have people walking all around the tank bottom. And that in a sheltered location, which FSRU locations often are, it makes perfect sense to make a kind of data gathering, data monitoring, data validation program to make sure that we are within limits rather than to open each and every cargo tank every 5 years. So it, of course, as mentioned, it is a big cost saving on it, and also a significant saving related to CO2 emissions, because when you need to gas free a tank, there is a lot of gas which needs to be handled and either sent to shore or burnt in the gas combustion unit in the ship. So the less tanks we open, the better it is, both cost-wise and for carbon emissions. I see time is running very fast, but this is the last slide I have, and I'll be happy to hear your questions in the chat later. I think that's it for me.
Wow. That's the end? Yeah.
Yep.
Yeah, no, thank you. Do you just want to take these 2 questions quickly? So Chris Pemberson is asking how you measure fuel consumption. So do you have a logger, or do you have a noonday report? I guess you must have a logger, so you make it so easy, but you have a lot of data. And then Jakob is asking, how do you balance the cost per vessel with this strategy, with different teams working with the data? I'm not sure exactly. Was it split out in different cost centers or one combined? I think that's the cost of your analytics department, how you organize that. I don't know.
Yeah, then both good questions. The first one, fuel consumption, we measure, of course, through flow meters to each consumer. And also we measure at start and stop of each voyage. We do this custody transfer operation, which gives the volume of the LNG tanks. So a combination of those inputs is used to calculate each voyage fuel consumption and boil-off gas performance. And the second question, the cost of our analytics department, in a way, that is kind of a split. Each company with a technical management contract for vessels, such as we have, Höglund G-Fleet Management, we are of course pressured all the time on operating costs. So it's not possible to sustain a full analytics department within a kind of a technical management contract as such. So the cost center for our group is a bit split.
Well, oh, sounds great. You make it all sound very easy. Fantastic. So we'll go on to Michaela's talk. So she's we're going to call it digital fleet management. So we're getting into more depth about how we're going to manage this digital side, how the operational tasks with decarbonisation, monitoring efficiency, improving in insurance compliance, and optimizing reporting. And she's going to show some great ways of visualizing where you are. So Michaela, I think it's quite unique among vessel performance people is she's working with vessel analytics, but she's also a naval architect. So she's got a domain expertise as well as digital expertise. And she's a manager of the Marine Digital Advisory Solutions at RINA. So I'd like to invite Michaela to give her talk. Thank you.
Hello, hi, thank you. Hello, everybody. So I'm gonna start sharing my screen. Okay, yeah. So thank you, Carl. So in this presentation, I'm actually gonna try to explain how we can improve the efficiency, how we can manage more efficient operations on the vessel using digital. As we all know, we have really important targets that have been set up in terms of the carbon footprint reduction and GHG emissions reduction by 2050. In general, the ways that the market will probably achieve such targets will be, of course, having new fuels, so reducing actually the carbon emissions of the fuels. Then, of course, we will have to add in technological improvements to the vessel. So understand that the vessels are going to be operated in different conditions, most probably. We have new technologies that can be applied to the vessels. And beside these two major topics, of course, we also have the new operational measures that need to be optimized in order to reduce as much as possible the carbon footprint of our vessels and of the fleet. So in all this, fleet performance management, actually, and digitalization can play a key role, giving the opportunity to monitor the efficiency, ensuring the compliance, so keeping the compliance under an eye, and actually prove what the technological improvements can achieve when installed on a vessel. So in general, we think that the key factors that digital management can add are, as I said, monitor and manage from shoreside. As Lars said in his presentation, it's very important to always keep an eye, help the crew on board to take the correct decision in ships that are assets that are very far away, but now it's needed for the companies to understand how they are behaving, how they are performing. Then we have also digital tools, for example, remote inspections, electronic logbooks, new way to have surveys on board that can reduce the burden on the crew on board, enhancing the compliance and again, assisting the vessels in the daily work and of course, reducing some costs most probably. Then we have the optimization side. So with digital tools, the company have the opportunity to accurately plan the vessel operations, vessel deployment, and then monitor it with efficiency KPIs. So digital tools is actually the way we will grant a flexible and future-proof fleet management, actually. So in order to cope on time with all the regulatory evolutions and enhance, of course, the business. So as I said, technological improvements are a key part of all this process. So what you can do with digital tools is, of course, after the system has been installed, I think about air lubrication systems, or for example, a reblading on a vessel, because of course the vessel is not gonna be operated anymore how it was. Of course, the providers of such digital solutions grant a percentage of improvement, but then as the vessel will need to cope with CII, for example, so with regulations that will follow the life of a vessel is not just one shot. It will be important to assess the real improvement after the installation, so the real gain based on data collected on the vessel, and then to monitor it over time in order to ensure that the achievement is kept and there is no loss of efficiency. There are several digital tools that could do this. Optimum is a performance management tool that has been developed by RINA. We've been working on this for almost 10 years. And it actually helps to monitor through KPIs, live monitoring alerts, analyze the data collected. So after the information is collected, it's possible to analyze it in the analytics, optimize it with trim and voyage optimization. And of course, at the end, it helps to meet the decarbonization regulations and the new targets. How is made this data collecting system? So usually we have a data collector on board, which is a piece of hardware that can collect the information from the different sensors on board, typically a navigation and automation, for example. Then we have the input of some data that cannot be collected through sensors, so manual inputs, for example, maybe a displacement or some weather observations from the captain. And then we have the addition of external data, for example, weather provisional models, so weather forecast. Then after we have this data, we stream it to shore. It's possible to monitor the information in real time. For example, we have a 5 minutes database. You have the opportunity to create KPIs, use machine learning techniques, create targets to understand if the vessel is actually performing in the correct way. And then you can analyze the information in order to better take decisions, for example, dry dock planning, analyze the interventions, and understand the CII or UI status of the fleet. But why are we saying that digital data automation is so important? What I'm showing here is are actually two scatter diagrams showing the same intervention on board of a vessel. We have had a reblading on a vessel. RINA has acted as a third party in order to certify the gain after the intervention. In the scatter on the left, you can see the speed power information collected through NUM reports. In blue, you have the data collected after the intervention, while in orange, you have the data before the intervention. As you can see, it's not easy to have two cubic curves. It's not easy to understand the real gain of this intervention. On the right, we actually see the same scatter diagram, but with data collected through a data collector installed on board. I'm sorry, the colors are actually on the opposite. So we have the orange after the reblading and the blue data before the reblading intervention. As you can see, it's pretty easy to understand that it was a very good intervention. We had really good gain. And I think in this case, the gain was about 18% in the contractual speed. So in the system, the new system have actually also tools. This is a picture of Optimum taken from Optimum. And it's easy to see how and to prove also to society, to the market, to prepare a press on LinkedIn saying that you have optimized the vessels, to prove how through data what you're doing to make your fleet more efficient. So this is a case study again of a different intervention we've done. In that particular case, the contract was set on 21 knots, again in a reblading activity. So the fuel consumption was of 127 tons per day at the particular speed. And we could assess a saving of 25 tons per day at that speed. This means 78.6 tons per day of CO2 saved. This without change of fuel on board. So of course, they optimized, changed the operational profile of the vessel, and then optimized it. Another way to use the data to actually understand how a fleet is efficient is to compare the operations of the different vessels in the fleet. So for example, here I'm showing a composed analytic dashboard showing two sister vessels that are operated in different routes. You see one is in red and one is in purple. The performance is more or less the same, even if they have, for example, a speed operational profile, which is a bit different. You see from the speed over ground histogram, and also the loading condition may be a bit. But this is something that you can do only if you collect data and if you have the correct tools to analyze it. Another thing that it's possible to do with the data is actually to create the hydrodynamic, let's say, digital twin of a vessel. So the modeling the response of the vessel in different sailing conditions. This is a dashboard that is actually provided to the crew on board so they can understand if they are in target or not. What we do is we predict the expected power that the vessel should have in the sailing conditions, and then we set a benchmark, a percentage benchmark, depending on the company requirements, in order to understand if also the specific fuel oil consumption of the engine and the fuel consumption are in line with the targets. How is it possible to build this targets? How is it possible to model a ship response? Actually, we have different techniques. The more standard ones are what we call the white box models. Sorry, they are based on physical models, ship design data, so ITTC techniques, ISO techniques, and so on. And it takes into consideration some loading conditions, some metocean effects, and they actually give the typical shape of a cubic fit. Usually, they give higher errors, but for some specific cases, they are very good models. Then we have the black box models. So these are pure machine learning models. So there are different machine learning techniques that learn through data and can actually predict, for example, the needed power of a vessel. They are very good in the explored domain, so in the training domain, but they are also very unreliable outside. They could be very unreliable outside because you never know if they're going to underpredict or overpredict. What is a mix between the two models is actually the gray box. So this puts together the plus parts of both models. So you have a white box model, which is actually fitted on measured data set. It's as accurate as a black box model, but actually it's more controllable and more robust. So even if you maybe have a slightly higher error as a black box, you ensure that, for example, you know if the model tends to overfit or overpredict or underpredict the situation, the performance of the vessel. So it's easier to use it in applications. When you have a way to benchmark, to build KPIs on a fleet, it's easy to have a visualization like the one I'm showing. So the full visibility of the fleet with the color on the different vessels based on the actual performance, understanding if specific vessels are underperforming, and then target them in order to understand what happened and if it's time to clean the hull or if a major accident has occurred. Another important way, as I've been saying in the first slides, is actually to optimize the operation. So after you have the data, it's possible to use the data to understand how the vessel should be operated in order to perform the best possible way. And then, of course, again, monitor over time. So in this, we have some route optimization, voyage optimization tools that are based basically, and of course, on the good model of a vessel is important to have the best possible model of a vessel. Then they give the opportunity to plan the voyage with a specific vessel, departure date time, arrival date time, set up constraints, and then optimize and understand if, for example, you need to reduce the speed of the vessel, or maybe the vessel needs to be more loaded, or you need to change the vessel on that specific route because it's never gonna meet the CII requirements. So this is an example of an output. As we can see in the table, we actually have as a result also the CII. So it's possible to understand and predict how the performance indicators that the vessels will need to comply with will be, and in this way minimize the cost, minimize the fuel consumption, and understand which is the best possible route. So for example, in this below case, we have a really good saving, 2.4, and this is just an example of how the two different routes, and you can see them on the screen, are. So they're slightly different, but as there is the bad weather coming in one of the two, it's actually important to avoid and to have a good saving. But what you can do with digital tools, what we all can do with digital tools, is actually trying to install a virtuous cycle with the vessels. So stay close to the assets, help the crew on board, and increase the awareness of what's happening on board in order to intervene on time. Collect the information, monitor it, and analyze it on the shore side. Optimize the operations of the vessel in order to reduce carbon footprint of the vessel, and again, continue monitoring the efficiency over time in order to intervene when needed. Thank you.
Wow, that's great. Thank you very much, Michaela. So, yeah, if you want to stop sharing the slides now and let Lars bring the camera on, and we'll get into, got some questions. I mean, just a warm up from me. One thing I noticed is you're both domain experts that have got skills in data, which are, while it's rare, maybe that's a growing trend. We're going to see more and more of this, and seems like this is pretty essential to do this properly. And another thought is you might find some of these software tools quite frustrating, because a lot of software tools being developed which sort of put the knowledge within the software. But if you actually know what you're talking about, you want to see tools where you can actually see the data and see exactly how it works. I don't know if maybe Lars first and then Michaela, is that a, would you agree with that this is where we're going to see more domain experts who are also digital experts?
Yeah, I think so. I think it's needed now in the kind of modern operation, with a combination of analytical skills and also, as Michaela mentioned, staying close to the vessel, actually knowing what makes a difference on board. So a combination, I think, is the key to make a good operation work.
Yeah, would you agree, Michaela? I guess.
Yeah,
obviously
definitely.
You would.
Yeah, I definitely agree. I find it will become always even more important with these new regulations, when you have to produce data actually to verifiers such RINA, and you have to be sure what you produce. So you need to have the knowledge to understand the data that you are collecting from the vessels and use it for different purposes.
Yeah, very good. Well, we've got 5 questions. They look like they're mainly for Michaela, but Lars, feel free to put in if you'd like to. They're all quite technical, but maybe we'll start, Michaela, with Klaus's. So did the blade supplier predict that would save so much from changing the blade, and then maybe do Dick's at the same time? I think he's saying about, I kind of missed your graphs about optimal dynamic trim, but I think he's saying you have to measure the trim to the centimeter to work out what the exact optimal trim is. I don't know if that's a very easy question.
Regarding the blade provider, blade producers, yes, actually they usually do CFD simulations. So in our contracts, as we act as a third party, we try to understand if the percentage that has been agreed in the contract is actually achieved. So yes, up to now, we were lucky, and all the interventions went well. But yes, with reblading, we assessed very good percentages actually of improvement. While for the trim, I actually haven't shown the trim optimization diagram. We use an inclinometer on board. We install an inclinometer on board with high frequency data, and then we, of course, evaluate the trim every 5 minutes of the vessel.
Okay.
The optimum trim tables are provided usually with CFD calculations, for example, depending on the vessel type, actually. For vessels where the loading condition doesn't change that much, such flowpacks maybe, we do sea trials on board. We can do sea trials on board. For other vessels, like container vessels, of course, we have very different loading conditions, and we perform such evaluations with CFD calculations.
Well, okay. So the next two, also from Michaela. So Peter Lee is asking, do you do data filtering before analyzing? I imagine you must do. And then USR is asking, using speed over ground for performance evaluation, are you taking weather or sea into account?
Of course, the data is always filtered. It's important also in the contracts. Of course, there are certain weather conditions, loading conditions to be introduced and considered. Regarding the speed over ground, of course, it's always better to use the speed through the water, if possible, if available. Often, what I've seen from my experience is that the speed through the water is not reliable. It could introduce errors in the evaluation. It's a sensor that needs often to be calibrated, to be changed, and may have present problems. So what we usually do is we take also into consideration the current for, of course, provisional weather models or hindcast information, but we try to take into considerations always the weather, of course.
Oh, so if we come to Veronica Jaramillo, who's asking, what's the main parameters to model optimization of fuel? I suppose that's the engine speed and the fuel engine power and the fuel consumption that you had in the thing. But I suppose, do you want to? Is there any more to say about that one? Do you think?
I'm sorry, I didn't get the question. Can you repeat it?
What are the main parameters captured to model optimization of the fuel?
Okay, we usually don't go directly on the fuel. We prefer to go on the requested power to the vessel, and then we recalculate the fuel through the percentage of MCR. We go back to the SFOC curve of the vessel, and then we calculate the target fuel. But the parameters, of course, to predict the power are concerning the weather conditions. Again, as I said, the loading conditions of the vessel. And of course, something that it depends if you're working with a white box or a black box, but something that can say how the vessel should behave in that specific moment.
Okay, Martina Guzzi, who had time to look up, she's with Geneva. You probably know her in IB Maritime. She's asking, have you got a future development for your roadmap? Maybe that's quite a long answer.
Of course, yes. Of course, yes. Cannot disclose.
Oh, okay, very good.
But of course, yes.
Yeah, oh, so fantastic. Well, maybe on coming to Lars. I mean, you made this all look so easy. I mean, I guess it can't be easy, but I guess you've got a very clear idea of what you're trying to do, which I suppose is the core of this. Is that do you think it's a?
Yeah, I think in one respect it can be treated as relatively easy, as long as you know what makes an impact. Then there are a limited number of equipment on board which actually make an impact on the operation. Of course, optimizing each of those equipments can be very, very complicated, but I think the overall view is relatively easy. At least in our segment, what we care about most is the cargo we have on board. The LNG, in the LNG segment, we use the cargo for propulsion power. So it's a bit different from other segments where you purchase your own fuel. We kind of eat all the cargo. And that's perfectly fine, but that means that as we are not the owner of the fuel, we need to kind of take care so that we do not use too much. And that is one very easy way of looking at performance, optimize our boil off gas. And then of course we have all the other, I kind of recognize some of the things that Michaela also talked about, hull performance, weather routing. This can be done as complicated as we want it to be. But again, in kind of, trying to keep it simple in order to make it work for those who are working with it. That's kind of the philosophy we try to apply.
Oh, very good. And last, maybe we'll take these two on the board here. So Akash, I've looked up, I think he's Vessel Performance Manager with Maersk Tankers in Maharaja, that's in Mumbai. He's asking, are you thinking about the fouling paint surface condition of the hull? That's something you didn't mention, but I guess it's a part of your maintenance role, isn't it? And then he's saying, if you are, what's paint decay percentage you taking into consideration over a year? Did you get into that?
Yeah, that's very detailed. I can't answer on that level, but that goes into the hull performance. We have a number of parameters we monitor to capture what is the kind of trend on hull performance, how easy does the ship glide through the water. And we're in contact with several suppliers also with new ideas, autonomous hull cleaning solutions while sailing. There are many new technologies which are seem to be cost efficient, because of course the more marine growth you can remove at frequent intervals without having to stop the vessel, without having to do diver work. If we can do something a bit kind of more easier than that, then it's a good cost benefit case on it. But of course the paint makes a good that's one big parameter in it, but I don't really have the details to that answer on the top of my head.
Okay, and USR's question, thrust analysis, thrust reading analysis, is that, I haven't heard that term before. I don't know if that's something you're familiar with, is it?
I'm not quite sure myself.
Actually,
but
yeah, sorry.
Yeah, go ahead. Yeah.
Okay, I'm actually not doing directly. Sometimes we have also thrust as a sensor, so as the information to our data. Usually we have some expert colleagues in hydrodynamics, like PhD colleagues in my team doing this kind of analysis. So I don't have it directly, but yes, we do also analyze those data if needed.
Okay, we've got a complicated question from Dick Jansen. I think he's works with the instrument company in Sweden. I think the main thing is how you measure trim. He's getting into the depths of inclinometers, but maybe this is too complex to handle right now. Is it?
I read the question.
Oh,
actually, 8% utility saving due to trim is pretty high quantity from my experience. So it's very high. I would go more like a 2-3% maybe. This is based on my experience. We actually don't install it on the bridge, as far as I know. Actually, I don't install it directly, but we have some technicians going on board, having it installed in, let's say, a stiff part of a vessel, so maybe close to bulkheads and so on. And we have a way to recalibrate it. So in our tool, we also give a tool to calibrate the inclinometer over time. So of course, if we see that the readings are not accurate anymore, they can do the calibration manually on board of a vessel.
Wow, and this point for Steve is more of a comment. I've just Googled GII-GNL and find it's the International Group of Liquefied Natural Gas Importers. So I think he's saying there may be updates given the complexities of LNG calculation processes. I don't know. That's more of a comment, I think, isn't it? Yeah.
Yeah, but I think comment on that. I think, Steve, that there is a bit of work ongoing in Gignal, but I'm not 100% up to date on what the updates are.
Yeah, this stuff just gets tougher and tougher the more. We've never even covered LNG performance before. I didn't realise it was so involved in it. Yeah, it sounds fantastic. Well, we're coming into the last 10 minutes now. There's a last question for Michaela about cloud. Would you want to answer that one? Are you on a Google Cloud or AWS, or are you using your own software? That's quite interesting, isn't it? Michaela?
No, we actually developed our own analytics. And we are also now moving to change a bit in the architecture to also use some standard business tools. But we developed our own custom analytics because, of course, it's a particular problem that we are trying to assess. The shipping market, ships are very particular and the needs are very particular. So as a cloud, we relied on Microsoft Azure.
Oh, very good. Yeah, so Dick Jansen would like to get into a debate on trim optimization, but maybe we'll I think that's another webinar, I think. But maybe as we go into the last 10 minutes, I don't know if closing words, I mean, if we want to sort of come up about where people in the industry should be going, what they should be aware of. I mean, the themes I'm picking up here, there's definitely a move from noonday reports to flow meters. I think you've made that very clear, Michaela, because that discussion often comes across. I think, Lars, you've shown that if you know what you're doing and the data, you can find out all kinds of things, but you need a lot of expertise and data. I think we're going to see a lot more expertise and digital tools working together rather than kind of against each other. That's how I'd summarize it. Maybe if you'd like to take a couple of minutes each to give some thoughts for people to leave the session with, maybe with Lars first, is it, do you think?
Yeah, I think you're on to it in a way. Expertise and digital tools need to go a bit hand in hand in order to aim for the right things, the right decisions. There's a lot of talk also of kind of artificial intelligence, autonomy, but I think at least for medium-sized players, it is vital to have some sort of expertise in order to make sense of the data which is coming in. I'm not fully ready to give everything over to an algorithm and do the adjustments on the fly. I think some sort of human factor needs to be in the equation still, at least for, maybe the foreseeable future.
Yeah, Michaela, I love that bit about the white, grey, and the black about the advantages and the weaknesses. That's something I've never seen, because normally people think you've got to either be the domain expert or the digital expert, and you're talking about combining the both. But the future is clearly that direction, isn't it? You need trying to give some closing thoughts.
Yeah, I actually think that it's pretty important. It doesn't really make sense to buy such tools. Actually, having sensors of the vessel is costly. Install these tools is costly. And you need the expertise to use the data you collect. So if you just go to the digital tools without knowing what you do, it's not useful. I think the companies would never be satisfied with it, and they would think that digital is like useless. But if you choose the correct partner, maybe if you don't want to have the expertise in-house, you can choose a partner. Or if you can find the expertise in-house, they really can boost the business and help in managing the vessel. I've seen in many companies that are using our tools.
Oh, that's fantastic. Well, we can finish there. And thank you very much, both of you. I think that's shared a lot and seen a whole direction of where we want to go to now. So I hope we're going to see all the audience again in about an hour when we're going to hear from Saga Wellco and RA Labs, which is a company owned by Williamson Group. So I'll pass back to Vida. Thank you. Well, mute. Oh.
Thank you, Carl. Well, I don't have anything new to say, just for the audience. Yes, we are back here with the session 2 after 1 hour. Take care.
Well,
we'll see you soon. Bye.